Most of the time you spend in CAM should be spent building toolpath. With Edgecam, it can be. Let's have a look at how Edgecam's virtual CAM setup technology speeds up the process for milling applications. The first part we're going to look at is actually completely programmed. The first setup is held in a vise and done in a 5-axis capable CNC machine. I want to begin by showing the machining simulation so that you understand what's been done here, and then we'll go have a look at how we put this together. The machining process begins with using a touch probe to locate where the stock is and to update the work datum. That's followed by roughing the part all over. The roughing process uses Edgecam's high-speed waveform roughing to efficiently remove material from all accessible areas. The first tool used is a large end mill, and then after that tool's done all the work it can, we switch out to a smaller tool for rest roughing. As we look further toward the end of the rest roughing, we can see all the areas where this tool has removed material, and then on to where we index and machine a smaller pocket that tool is well suited to. Following roughing, we move into finishing work, both counterbores, profiles, outside walls, pockets, floors, which also includes hole drilling. The hole drilling tool path is very efficient, recognizing areas where we can use the same tool in multiple areas, and then moving on to even full part deburring. It makes sense to deburr as much as possible at the CNC machine, and that's exactly what we're doing here with this final tool used in the program. Finally, we move back to 0-degree position and deburr all the top side pockets, holes that were not already countersunk, and that'll include a couple of lower steps. Everything here is collision checked, and the visual of simulation allows us to confirm whether what we see here matches our intent. In this case, it does. The machining process represents what I intended, so I'm going to go ahead and generate code. The edit free NC code can immediately be sent to our CNC machine where we can proceed with machine setup and operation. Let's rewind to a fresh file where we can see how quickly Edgecam can put together the virtual CAM setup for this part. With the timer running, I'll drag and drop the file into Edgecam and quickly open the solid. The orientation of the part actually works for this setup. We can see that Edgecam also knows the bounding box size, and using that information, we'll go ahead and input the stock material size of the blank we're going to use, and I have a specific amount I want for face-off. We can see confirmation of the stock and that Edgecam knows both the part and stock dimensions. And so next we'll go out to our Fixture Database, which represents common work holding fixtures in our facility, and quickly pair one of those common vices to our part without needing to build a CAD setup to do it. Now that that's in place, we'll connect this to our CNC machine. So out of all the machines in our facility, we'll select the one that's going to be used for this setup, the tooling package, and then the datum and how the part and machine are assembled together. Edgecam shows us the result. This is what I want, and we'll move forward to feature recognition. Automatic feature recognition is very easy. We'll ask for the pockets, bosses, open pockets, holes, etc. And we can also put in user parameters to control the results. We see the resulting features, and at this point we're ready to carry forward to the machining tab and start creating toolpath. That entire process took just about 1 minute and was very quick to put together. Now, no doubt you have some questions about some of the steps along the way, and what we're going to do next is go in a deeper dive and have a look at some of the critical pieces of technology that make this possible. Let's turn off the timer, and then we'll load a different solid for our deeper dive. The file we're going to work with next does not have simple box type linear edges to it. So part orientation is going to be a little bit more tricky, and we'll see what happens here. First of all, notice that when Edgecam loads the part, it's oriented with a long edge parallel to the x-axis. Now that may not be the end result that we want for our setup, and I can quickly reorient that using options available in the setup window. But I also want to show how Edgecam has actually already done us a favor in how the part's initial orientation landed. So if we go into our Preferences command and out to the Solids tab, we're going to look at our workflow alignment options. They allow Edgecam to determine whether a part's best suited to milling or turning, and if it is milling, then whether it should be set up for a vertical or horizontal machining center, and where our preference for the datum might be. The point isn't to get everything right all the time on any solid loaded in, it's just to get the part into a suitable orientation that helps us quickly put the cam setup together. So let's go dump this file and reload it with the preferences off and see what happens. When we go open the solid, Edgecam always zooms directly into the part, and I'm going to want to zoom out so that we can see how far away the part is from the datum. And you may also notice that the part is upside down from the perspective of our setup. This is the orientation that the CAD designer happened to build this part in. Well, we can quickly reorient it for CAM using Edgecam's align component command, where first I'll flip the part over, and then looking down from a top view, I'll select some linear edge, and that'll clock up to, in this case, the x-axis, and then I'll just chase that edge a couple times to get it clocked to Y, and then finally the direction I want. And then third stage of the command, we'll specify that, say, the center of a hole, and use that as our part datum. So it was very easy to recover. But with the preferences on, we don't even have to do any of that. Let's go back and turn those preferences on. Edgecam comes standard installed with the preferences on, and most users probably want to use that, and you may want to consider where you want to set your datum as a normal course of action. And Edgecam will load a part with these preferences in place, and that allows the solid loaded in to be at a pretty convenient part orientation that we can then quickly reorient as needed for individual setups. Now when we open a file, you can see that Edgecam has a wide range of files that it supports as solids, and what we do on one solid works for all of them. So it doesn't matter the format of solid that I'm using here, this applies universally. Focusing on the setup window to the left, we can specify whether we're doing milling or turning, and material. Now the material list represents the materials that you have entered in your database, common materials that you cut at your shop for feed and speed lookups. Then, as we've shown earlier, Edgecam knows the bounding box size of the part. Well, let's go look at how we can easily specify the work datum for our setup. So when we expand that option, notice that we can select common positions around an imaginary rectangle, but we can also select specific part features, and the datum can be easily set. We can also quickly change the part orientation. So I put in a value and can move the part in the x-axis or y-axis or z-axis direction. Similarly, we can put in a value and rotate around x, around y, and around z. I'll put a bit of an odd number in, and then we'll rotate around the z-axis and look in through the top view to get an idea how this would look to the CNC machine. And notice that Edgecam's bounding box values update correctly. If I rotate it back to where it was, again we see different numbers used for the bounding box. Now I'm going to go ahead and use the align component to pick the shorter linear edge on the part and clock that up to the parallel to the x-axis, and again the bounding box updates. The key point is then we've done a lot of different part orientation, and now I'm going to use a command called insert stock that allows us to bring in a different model and use that as our stock model. In this case, that could be a casting or forging or previously machined part, and notice that that part lands at a matching orientation to the part we're using. That is not an accident. Edgecam understands the transitions that we brought our initial part through, and it orients this solid the same way to match for the setup. Okay, that's great. I'm going to go ahead and remove that out of there, and Then we'll go back and we'll look in through a top view again and render the part and look at a couple other things in here. Again, looking at our part orientation, I can quickly go use the fit stock command to add a specific stock blank size. So whether we use fit stock or whether we use a solid model as I just did, either of those options are very easily done. Now with the fit stock, you can control how much extra amount is put on the sides of the workpiece. If you do nothing at all, then the part will be in the center of the stock volume. Again, the user's in control. After selecting OK, the rectangle is put on the part, and now that Edgecam knows the size of that piece of material, so we can see, you can set the datum at this point. So whether you set the datum before stock's placed or after, completely up to you. But now is when we can go out to the Fixture Database using the stock we have. And Edgecam's Fixture Database allows us to catalog common work holding fixtures that we have in the machine shop. Edgecam is aware of how large they open because that's part of what we put into the database. So when I go choose this particular vise, we see that the part's centered up, but also that if I open the, or if I request a 90-degree alignment, that the vise jaws have to open much larger, and immediately there are a lot of vices in our Fixture Database that are no longer valid. Well, that's because those vices can't open large enough to accept this particular part. Okay, good to know. So if we go and look in from a front side perspective here, and think about the height perspective of assembling the vise to our setup, we can put in some quick information based on the part size that we already can see from the setup window. So I'll put in how much material I want to stick out, and there we go. We can quickly see that previewed and be sure that this is exactly what we want. Well, in this case, I'm going to move back to the 0-degree position. Many more vices become available because they can open large enough to accept this. And I'm going to go select the 5th axis vise that we have here. And we can see that the part correctly lands on the selected step. So putting a fixture in from the Fixture Database is very simple. It doesn't require any CAD assembly work at all. Put the fixture into the database as a one-time thing, and we can immediately use it anytime we need to. The final step in this case is pairing this to our CNC machine to create the virtual CAM setup. And so we can go through any machine that we have in our machine shop. In this case, I'm going to choose a vertical machining center with a 4th axis that's on the right side of the machine table. And so here it's important to both establish the datum that we want to use for our setup and where on the table the part will be located. After inputting both, Edgecam will show us a preview of how the part's placed on the machine table. And the reference that I used is to put the vise based on the center of the table of the machine. So while it looks like it probably has some clearance off the rotary housing, I'd like to increase that a bit. So I'm going to put in a 6-inch value and then move the part further down the table. That would be part of the instruction I'd give to the machinist about where we've roughly located that and where the specific of the datum is, and that setup will likely work real well. So as before, this is the point where we would now go out to find features. The feature recognition process is super fast and the features are very quickly created, and we're ready to go build toolpath. Now, what happens if I have a model change? I'm going to reload this file and replace it with a new solid. When we do that, a couple of things to note. First of all, the part, the new solid, lands in the same orientation as the original. Again, that's not an accident. And the features are automatically updated. And then again, we can head on to the machining tab and build toolpath. Let's open another file that will look at what would happen if we had a CAD assembly of the entire machining setup, and how would we work with that. Up to now, we've looked at individual solids where we add the stock, add the work holding in Edgecam. So in this case, the CAD work's already been done. We've got a part that's been cut in a flame cut or water jet. So we have a piece of material that's going to be specifically located on a couple of angle plates. There's some stops here, and we're going to set a 0 point based on that. So I want 0 right there on the corner. We'll snap to that. The solids immediately move to that position. This is going to go into a horizontal machining center, so I'm going to set up my datum to be what I prefer to use for horizontal machining centers, and then since this solid assembly contains everything, we'll say this solid is the stock, and it's put onto the stock layer automatically. So I'll hide that and the finished part, and then I'm going to use a similar command for fixtures and say all of you visible stuff are my fixtures. And then connect this to the CNC machine. In this case here, I want to put this into a horizontal machining center. We'll select the machine tool. We'll select the datum that is our 0 point and how the part should be assembled to the machine. The machine's loaded in. We can see the part lands on the table exactly as we would want to. If we needed to adjust it, similar to the previous part, we could. At this point, I'll turn off the display of the machine, the work holding fixtures. Now there's many layers in the part. I'm going to quickly strip away the layers that aren't needed. It's not an Edgecam requirement, but it certainly helps with part organization. And then again, we're ready to go to find features. You can find the machinable features in this particular part. Since there's multiple solids, Edgecam asks me which solid. I'll select it. We see all the solids visible in the feature window to the left, and when feature recognition is done, I can see which solid has the features. And again, we're ready to move out to the machining tab and begin the tool path creation process. Let's summarize what goes into the virtual CAM setup. First, that includes the component, which is the finished part. In this case, we're talking about solid models, and when a solid is loaded, Edgecam offers the setup window. The technology in this window assists with quickly orienting the part for the machining setup and assigning the work datum. This is very easily done, and then we can move on to the commands on the Setup tab to add stock to the part, work holding, which is optional, and to pair the setup with the CNC machine. The point is that Edgecam's virtual CAM setup is both fast and flexible. Our interface technology allows users to quickly create the CAM setup for milling, find machinable features, and move directly to building toolpath. And best yet, this is all done with out-of-the-box capability. Hexagon technology and expertise is helping our customers improve manufacturing processes and improve product quality. We invite you to bring us your machining challenges.